I'm Abhik Roy Choudhury, a professor at the Department of Computer Science, and it's my great pleasure to introduce Professor Carlo Ghezzi. Carlo is from the Politecnico Milano, where he has been for many, many years. Carlo's research is broadly in the area of software engineering, and as part of his contributions in research and education, he is a winner of many awards, including the Outstanding Research Award in Software Engineering. He has of course heralded the main conferences as well as been the editor-in-chief of the Software Engineering Journal, the ACM TOSEM, and he has also been the president of Informatics Europe, right? Am I correct? The
Yes.
President of Informatics Europe, and of course been in many committees for funding as well as hiring over his very distinguished career. So also apart from his very distinguished research career, also he has contributed to education. So many of us are familiar with the book written by Carlo in software engineering. And he has also mentored many students. So his students are currently, his former PhD students are currently faculty members in many top universities in Europe and US, including Imperial College. I know only a few of them, Carlo, but including Imperial College, as well as in University of California, and so on. So without any further ado, let me hand over the floor to Carlo, and really looking forward to this exciting presentation. Please.
Thank you very much, Abhik. Okay, so welcome to this talk, which is at the end of the marathon. You're probably very tired. I'm very tired. You know, I've been being here in the audience and following all the presentations. You know, I may go shorter than expected, but it very much depends on how much you want to discuss with what I'm going to say. I also want to thank the organizers for inviting me to come here. I was here, I checked today, about 10 years ago. And this is actually what I was talking at that time about, which was basically, you know, describing what I was doing in a pretty large project funded by the European Research Council at the time on context-aware systems. That was a very technical presentation that I gave at the time. Then, you know, a number of things happened. A number of things, including the fact that I retired, and I don't have access to funding research more. But that's not the main reason why I changed. You know, maybe when you get old, you try to look back at what you have done, how the world has been changed by the work that we have done in the past, and try to understand, you know, whether we are going in the right direction or not, and you know, whether things should change or not. So a kind of critical view about the state in which we are today. And this is basically what I'm going to talk about here. As I said, I would like, you know, to make it let's say a starting point for discussion. I may say things that you disagree with. I mean, this is not a technical paper in which I'm going to, let's say, prove a theorem. It's more an opinion statement. But I wish I offer to you a way to reflect on the state in which, of the world in which we live, which is shaped by the technology that we build, and, you know, maybe think more about what we are doing. Okay, so this talk, as I said, is non-technical in a technical sense, I'm sorry, I cannot see what I'm projecting. Okay, so it's more a reflection on the effects of what we are doing on digital technology that we develop on society and individuals. And, you know, basically when I say digital technology, what I really mean, I have to say, is software, because everything becomes live through the software that we build. And what I want then to discuss with you, reflect with you, is whether and how much all this has to do with the way we educate people and the way we do research. Okay, so that's basically what I would like to do here. So first of all, though, I want to set the stage with some kind of historical perspective. So we are here, but, we can learn in some sense also from the past, from history, not just, our recent history. Okay, so I'll be very brief here, but I think it's important. And as I'm an Italian, I like, the classics. So I would like to start with a Latin citation from Cicero, which talks about history. So history is not there just, because, it's nice to understand history, but history actually is there because we can learn from history. So history is, as he says, is the light of truth, the life of memory, the directress of life, and blah, blah, blah. Okay, so a little bit of history. The history, what I want you to reflect on is the fact that science and technology have proved to change people and society. And science itself evolves over time in history. You're probably, aware, if not, I briefly tell you something about, the findings described by a philosopher. The philosopher is Thomas Kuhn. The book is The Structure of Scientific Revolutions. And what Thomas Kuhn says is that, the evolution of science goes through radical changes and then periods of normal science. Radical changes are changing paradigm type of discoveries, which radically change the way we see the world. Okay? And the second part of this is that those radical changes, those paradigm changes, also happen in society and in individuals. Okay? By the way, it turns out that this book by Thomas Kuhn turns out to be the most cited book in social sciences. But what is important for us here is to understand that changes in technology, there are radical changes in science and in technology. Those radical changes are followed by some kind of normal science, and those radical changes are also the starting point for radical changes in individuals and society. Okay, so that's Thomas Kuhn, but let's see, let's move back even from there, and let's move back to the 17th century. And it's important, to go back here because the mother of all radical changes in science has been something that was invented in the 17th century, which is the scientific method. So the scientific method, and by scientific method, I mean the contribution of these guys, which you may recognize here or not, but if not, I tell you, Francis Bacon, Copernicus, Galileo Galilei, Descartes, Newton. I mean, these guys are the inventors, at various stages of the scientific method, okay? But the scientific method is important because through, because it was the starting point of the explosion of modern science. Which means, the physics as we know physics today, mechanics, thermodynamics, and, chemistry, I'm not mentioning all of them. Eventually, in 2 centuries after, electricity. Okay? And, those radical steps of change, which were originated by the invention of the scientific method, led to the Industrial Revolution. And the Industrial Revolution really was a real radical change in people and society. Well, this is a picture taken, by, in the England in the 1700s or early 1800s, with the industry that was born there. And, what are the disruptive changes that were brought by these revolutions? Well, look at this. We were in a world which was based on agriculture, farming, craftsmanship, small commerce, and, there were new things that didn't exist before. Factories, machines. So that's, machines are there. The machines that, people use, didn't exist before. They used animals, to automate work, right? But machines were invented because of those revolutionary steps in science. And, another radical change. People used to live in the countryside. They were farmers. Okay, the big cities exploded because the factories were located in the cities. So there were massive movements of people from the country to the cities. Well, the organization of society changed. It moved from feudalism to capitalism. So people who own the means for production, right? And so these were radical changes, okay? Now, if you want to read something, much better than what I said here, I tried to summarize, but there's a wonderful book by Yuval Harari. He's a very nice guy. And, he wrote interesting things, and he's taking interesting positions publicly. So Yuval Harari in this book talks about the history of humankind. And what he basically says is that, humanity, changed, in the last 3-4 centuries, in a way that is, more than the changes in the previous millennia of the human life on Earth, okay? And that was because of science and technology, okay? And we continue to see this. But now, let's see what is different in, what digital technology has brought to the table, okay? My claim is that, the digital revolution is even more disruptive than the Industrial Revolution. Okay? And I wish to, let's say, convince you that this is the case by looking at 3 dimensions that I call breadth, depth, and speed. Okay? Breadth means that all aspects of human life and society are touched by digital technology. The Industrial Revolution didn't touch the individuals much in their homes, for example, except for bringing electricity, if you want, into their homes at some stage. Okay? But digital technology is also touching us individually. So all aspects of society, of humans, are affected. Second, depth. The changes that are introduced are even more radical. They change our behavior. They change our way of thinking. Third, and perhaps most important, the speed of change is unprecedented. We are talking about the Industrial Revolution, which took centuries to evolve, from initial engines, they were steam engines. And then, eventually in the 1800s, it became electricity, okay? But here we are talking about decades. And what is the effect of speed? Well, the effect of speed is that humans are adaptive animals, yes, but dealing with the speed of change became a real challenge. And it's one of the challenges that is, for example, forgetting many of us, many humans behind, leaving them behind. So these are radical changes. If you want to summarize, basically what I'm saying here is that if you really think, what's happening here is that through technology, we really are creating a new world. That's the basic difference with respect to the Industrial Revolution. It's a new world which is both physical and cyber and virtual. And the border between the two is disappearing. So it's a new world with new laws. There's new space and time dimensions that humans didn't experience before. So the ubiquity that you have, today, ubiquity in the sense that you can talk to, collaborate, interact with people who are not co-located with you, something that didn't exist before, except with long delays. But now we do it in real time. So time and space dimensions are changing, and this is changing us. I didn't tell you, but of course, anytime you want to disagree or you say, okay, stop, just, tell me. Yeah, but, I like to discuss, if you wish. Okay, so what makes them special? So, yes, so what are the reasons why digital technology is so, disruptive, has been so disruptive? Well, of course, on the one hand, we have the physical machines. Without physical machines, nothing would have happened, like in the Industrial Revolution, right? Then, we have the ability of those machines to work together, second dimensions, through networking. If we didn't have networking, all this would not have happened, okay? Third dimension, those machines are able to interact with the external world, with humans, with people, devices, environment, okay? So there's sensors, actuators, interfaces to humans. Fourth, and most important, software. And the reason why software is the most important, because it turns those machines into universal machines, which is different from the machines of the Industrial Revolutions, right? So you can program your computer to do things. You can incorporate in your machines behaviors and rules. Okay, so they're programmable. Yeah, we all know, yes. But it's impossible. It's important to reflect on this. And the fact that they are so universal, it puts a lot of responsibility on those machines and on the people who make them, operate with humans and with the world. okay? Right, so, and the evolution, just to summarize again, the evolution has been also in the fact that those machines are kind of disappearing. So there's this phenomenon of disappearing computing, because computing is everywhere. So we used to, like, again, in the Industrial Revolution, you have the technology on one side and you have the real world on the other. Now the two are merged, and technology is disappearing in the real world. We have distributed sensors, we have ubiquitous computing, we have ubiquitous access. So we are a world which is a blend of the physical and the digital, and we don't see the boundary. And the meta people are claiming that we are moving into this world in which the two worlds actually are completely seamlessly integrated. All right. So as a summary of what I said so far, is that we can say that designing technology is the same as designing society, or even more generally, designing the world. So that's a huge responsibility on technology, which is the design of the world. For all of us, that's the point. So we have seen that digital technologies are giving us unprecedented opportunities. I mean, I don't need to convince you guys, right? We all work on this, and we believe that this is true. But we also know that through this, and because of everything I said so far, it also generates unprecedented threats for us. And, we have been talking a lot here about, privacy violations. We want to defend our own sphere, biased decisions, echo chambers. We haven't talked much about this. People surveillance, platforms, and sovereignty. We are living in a world in which we rely on platforms who are above nations, governments. Okay, you probably remember, Twitter, X, at some stage, shut up President Trump, which is a very good move. But, the question is, this is a platform which provides service to us. Is it acceptable that, a platform has such power, which is at that level, it goes beyond, governments, nations, the democratic processes, even? So, these are open questions, of course. So, I'm just saying this. And today, we are talking a lot about generative AI. And actually, if you think more, the real added, behavior to our systems is that generative AI is moving, what we've been doing so far, which is more automating things, from automation to autonomy. So the technology that we develop behaves in an autonomous way. So all these are potential sources of threats. So basically, that was the setting. So now the questions that I want to discuss with you is, given all this, why should we care? Okay? So, and basically here, I'm telling you why. So, software technology creates the new world, as I said. So the question that we should start asking is, are technological skills enough to make decisions about what technology should do? If this is true, that technology is creating a new world. Are those decisions about how the new world is shaped or should be shaped, should be just in the hands of the people who develop technology? Or is economy, the market, responsible for those decisions? Should it be governments? Who should be in charge of that? Is this something that just happens spontaneously? So, if you want, the questions are all humans in charge? Are we? When I say we, I mean we as a collective, body of individuals around the world, we, humans. Are we still in charge? Or is they are in charge? And who are they? So these are questions I think that we should ask. And then, so is the way we do research and education leading to responsible creation of this new world? I think that the key word, is responsible here. And I will use this word, several times. Responsible creation as opposed to, let's say, self-evolving without particular directions, but actually some directions are there, of the world. Who is responsible? Who takes responsibility? I think everybody should take responsibility. We should all take responsibility. But so, how do we exercise this responsibility? So, what can we do? And of course, I believe that the main question is, can we ensure that technological developments are aligned with recognized human values and societal values, and if you want, and values of Mother Earth? We live in an environment, which is threatened. And our technology is also part of that, right? In the environment. So how does this affect research and education? So I would try to, increasingly go into these questions. So why should we care again? So remember, I want to dig more into this issue. We are living in a software-defined world, increasingly, if you really think. Because, the world exists today through software. Software defines new entities, new actions, new behaviors. The rules of the new behavior are embedded into software. And, design responsibilities and skills require, so go beyond a pure technology. Now, I'd like to point to a very interesting contribution which is not very new. So the contribution is this one. I don't know if you ever saw this book. So this book by, what's his name? It's coming. Okay, Lessig. Okay, Lessig, Lawrence Lessig is a constitutionalist, a professor in the Harvard School of Law. And he came out with a very interesting book in the 90s, in which he states that code is law. So what is the meaning of this? Again, so the world that we are creating is regulated by software. So the laws of the world are embedded into software. What citizens can do mostly now is embedded into software. What you can do, the way you pay taxes, the way you can subscribe to certain things. So the laws of your behavior are encoded into software. Okay, so if this is true again, where are the responsibilities? Traditional, how does the society decide about the rules that govern the behavior of the society? Well, largely, in most countries, not all of them, unfortunately, through democratic processes. Okay? So through democracy, you establish some consensus on how the rules of the world in which you live, your society, should be shaped. Okay? So there's kind of well-defined human processes and deliberations, and people participate. Citizens have the right to express their opinion on that. So responsibilities are clearly defined. Of course, you are not in charge of, let's say, certain implementations of certain rules, but you can participate in the way. So what's happening now in the digital world is very blurred. I mean, who is responsible? Who defines those rules that are embedded into software? So all this is opaque. You know, if there is a word that really describes, you know, the world in which we are, is opacity. We have very little visibility on why certain things happen. Okay? So, and, you know, if there's, I would call it, you know, I've been talking to a philosopher on this, and you know, she has been using always this word, which is the epistemic opacity. Epistemic means that it's intrinsic in the world that we are, in which we are. So there's opacity at all levels. Responsibilities, who is in charge of, no explicit assumption, but also the software. I mean, we all know about software, right? So we all know that if you look inside your black box, it's not very white box. It's hard to understand, right? So the rules are contrived. Okay, so there's a lot of opacity in software-defined rules, even if you want to open the black box, right? And on top of this, there's complexity. So there is opacity because if you open the black box is a mess. Software systems that govern our society are extremely complicated, right? It's hard to understand what exactly they do. So there's complexity, and this adds to brittleness. I mean, and again, and of course, everything, becomes even more and more complicated because of autonomy. Right, now we have, software that is autonomous, and the rules of behavior of those autonomous pieces are even more opaque. Look at AI learned components that are becoming more and more part of the systems that people build today. And, the AI people have been talking about, explainable, making those, explainable AI as a goal, but because that's very hard. Those components are intrinsically hard to understand. I mean, if you have a component which is a model, a machine learning model, they are, they're impossible to understand the why. So why they do certain things, right? So, and all this complexity actually, again, I mean, is not really new. There's an old paper which, if you go there, some of the considerations were already there. So Fred Brooks in the late 80s, when he was saying that, software systems are the most complex artifacts that humans ever created, right? And unfortunately, he said there's no silver bullet, to fight against this complexity. So this is a real problem with the systems that we build. So the basic questions now, so if this is the stage, who is directing our future? We, market, governments, technologists, none of them, all of them. Can we direct? So that's try to see, you know, how can we direct our future? Shall we direct our future? But if we do that, now the question is, if you want to understand, you know, the reason why and how we can direct our future, I think we have to agree at least on some basic principles, okay? Or founding principles, if you want. And by founding principles, I believe that those principles should be the principles of what I call, and I will go back later to this, of what I call digital humanism. So the principles upon which we have to build our future are the principles of digital humanism. And which means that, you know, let's say in two words, which are very simple but very hard, of course, to reify, that humans should be at the center. The goal is that humans are at the center. Technology is for humans, not humans for technology. We are not the feeder of technology. We want to direct technology on our needs. You know, the term digital humanism, actually, if you go back again to history, you know, humanism was a way for, you know, at least in the West, you know, for society to move into the modern age, putting, you know, people at the center. Okay, well, we can discuss again a lot about this, you know, what it was before, but that was, again, you know, one of the things that was at the basis of all the changes that we have seen. So we want to think about these principles to understand the way we want to go. So now, let me briefly switch now more to software engineering. And let's try to see, so how does really digital humanism can affect the way we engineer software, okay? So that's basically what I want to discuss here. You know, of course, when I talk about, again, you know, somebody already objected once, well, you're talking about software in general, but there are many kinds of software, of course. You know, what I'm talking about here is not if you're writing software for a driver, or you're writing a piece of technical software, that's, you know, or you're writing a compiler, that's a different story. But, you know, what I really want to discuss here is most of the systems that we write, which are systems in which software is of the so-called socio-technical nature. So software systems in which, you know, there is a system that interacts with people and with the rest of the world through people. Okay. I'm not, you know, another important thing is, you know, maybe that we should discuss, but I'm not touching this, is the type of responsibility that you have with respect to designing systems with respect to the environment. That's another extremely important area, developing technology that is sustainable for the environment. Okay, and we are part of the problem because I mean, if you're probably aware of the fact that, you know, digital technology is also responsible for, you know, producing, you know, carbon in the air and responsible for the problems, you know, with the sustainable society. Okay, so I'm not talking about this. So, but this is like, yeah, so this is digital human. Let me skip this. Okay, yes. Now, why, let's reflect a little bit again, you know, on why it's important to rethink about the way we develop software. So even in the 1990s, you know, there was seminal work in requirements engineering, which is a branch of software engineering by these two guys, Michael Jackson and Pamela Zaid. And you know, in their foundations for requirements engineering, what they say is that, you know, when people develop software, they develop software with the purpose of achieving certain goals and satisfying certain requirements in the world, in some, physical situation which involves humans, which involves the environment. So, and what they have to do is first look at the world and then build a machine that, through software, okay, that can, achieve the goals that you're interested in and satisfy the requirements you're interested in. But the point is, as I said, that requirements and goals are found in the world, and you build a machine to reach those goals and satisfy those requirements in the real world. To do that, the people who develop software, they have to understand the domain, the environment, its properties, make certain assumptions, and then, indeed, develop a machine. And this is the only kind of simple formula that I'm writing in this presentation. Their duty is to build a machine that, given the environment in which it operates, entails satisfaction of those requirements. So engineers have an obligation to show that the machine they build, in the environment in which the machine is embedded, satisfies the requirements they defined. Okay, this was known, yes, and we all know that requirements should express human societal concerns also and values, and environment also refers to humans and societal properties and assumptions. This is well known. But if you really think more about this, identifying, negotiating, setting, trading off goals and requirements, because we all know that there's trade-offs, there may be conflicts among those. All this so far is largely dominated, is an activity that has been largely dominated by software engineers. So they are the ones who are responsible for understanding those. And indeed, in fact, in most cases, software engineers mostly focus on what they call functional requirements, and also on some non-functional requirements, but they're mostly efficiency. It may be security, hopefully, in many cases, safety. But, they, mostly tend to focus on functional requirements. For sure, they're driven by the objective of setting requirements that they can put into technical terms, because that's their job, right? So human, societal, environmental requirements, they're very often ignored, or they're hidden, or they're implicit. In many cases, they are unknown unknowns. So which means that, engineers don't even know that they don't know certain things. They, I'm not saying consciously, but mostly unconsciously, ignoring those. They are, and we educate people, and this is right. They have to be technical people. They have to be able to manage technology in an efficient way. So the unanticipated, and most important, there's one thing that people ignore, which is, if I satisfy these goals and these requirements, do I enable other goals to be satisfied, other requirements to be satisfied? So if, very simple and stupid example, if I get your name, your data, to provide you some service, do I anticipate? Well, today, yes, but we know that it wasn't that, like that in the past. Do I also allow a potential use of those data for other purposes? So to satisfy those requirements, do I, consciously or unconsciously enable other things? What are the potential consequences of those? This goes beyond what normally software engineers do. And then, of course, implementation is owned by software engineers. But all of those, actually, they are all handled by technical people. And, I think that this is a problem. This is the problem. So as a result, we deliver a system very often in which, decisions that are seemingly technical, actually they have non-technical implications. They allow certain things, which means that then people have to do ex post patches to mitigate the effects of those decisions that have been made in the first place. So you discover, for example, that your system provides, biased recommendations, okay? But you discover afterwards and try to put a patch on that. So to privacy violations, unfair operations, and blah, blah, blah. So is this tolerable? No, I don't think it is tolerable. It is not, because technology moves, from the pure technological speculation into practice very quickly. It's the speed dimension that is important here. Speed dimension means that you deploy things that have threats. So the question is, can we do better by moving from ex post to ex ante? So can we take care of that before? Of course, it's hard to anticipate all possible uses. Future uses of the system that you are developing. Yes, but are we doing the best we can do to try to anticipate that? I don't think so. So can we be better systems? That's the question. And of course, what do we mean by better systems? A better system for a better world, right? The world in which we live. So can we build systems that comply with the principles of digital humanism? That's the question. Now, if you're asking this question, you are opening the set of questions that you should ask yourself to questions that people who develop software almost never ask. And to understand what a better world is, you have to start reasoning about what is good and what is bad, what is right and what is wrong. Not just about the functionality that you want to offer. Is that right or wrong? Is it good or bad? And when you enter a discussion about good and bad, or right and wrong, you enter a domain that is called ethics. So ethics is the branch of philosophy which discusses the notion of good and bad, right and wrong. Okay? But also enter a very difficult area because, good and bad, right and wrong are not black and white. There's continuity. There may be differences in culture, in understanding what they are. They may vary according, to the situation that you are, dealing with. But before we enter that, and we will talk a little bit about how you can address those questions. But before, the question is, are those questions part of what we do or what we teach? Well, of course, this is a yes.
But concretely, what can we do with that?
I think I will try to elaborate a little bit and tell you about some people who are doing some work in this direction. Yeah. So are those questions asked? Do we ask those questions when we identify goals and set requirements, when we implement and assess alternative solutions, when we validate, verify, verification, testing? Do we test for fairness? Yes, today we start because we have been, but we have never done it. Okay, yes?
Just a point that during research, you might not ask those questions. Sometimes yes.
Yes and no. Yes and no. I think that you should ask those questions of some research, and also.
I didn't mean that you shouldn't. What I mean is that in practice, one may not be asking.
Well, first of all, not, as I said, if you're doing compilers, and you're doing, code optimization, probably not. Maybe you can ask, whether they are energy consuming. You can ask questions like of that kind. But, but in general, in most of the systems, yes. And in the way, you educate, how systems are built, I think yes. In the tools that you may provide to support them, there may be tools and approaches and methods and, that can address these issues. Okay, but let me, I would probably...
I agree that this is important, certainly, having the ethics being taught. So currently it is taught as a separate course. All undergraduate students take one course.
Which is good.
Which is good, but
not enough, yes.
So what I'm wondering is your solution more process-oriented, like for every software engineering project, every team there has to be one person?
No, I'm not saying that. I'm not saying that. I think it really depends. Again, I mean, the whole point is that, if you say every team should have Baba, you're taking away responsibility. What I'm saying is that it is part of your responsibility to understand whether you need that kind of support. Okay? But, so it's a question of responsibility, I think. Okay, so, yeah, so just to, years ago, again, look back at history. Years ago, you remember there was this, important contribution, cited by many people, by Jeanette Wing on communications of the ACM, in which she promoted computational thinking. So she was saying that, computational thinking is important, for everybody in the modern world, and I agree. What I'm perhaps claiming today is that in the year 2020, ethical thinking for technologies is at least as important as computational thinking is for everybody. So we need a world in which people understand computational thinking, but those who develop technology need to understand about ethics and the ethical implications of what they do. Yes?
There's a danger for this. A lot of the people, AI, a lot of the people I know who talk about ethics don't know really squat about ethics, but they are I'm not talking about you, but they are self-described ethical people. And then you have things like the famous biases in machine learning on the data, and the biases, when you want to do stuff on the data, in reality, you probably want to exploit the biases of the data, because they are actually appropriate for the population you are looking for. And it might be totally unethical to actually remove those biases. So I think these are complicated
I agree with you, but what I'm saying is that most likely it is more ethical if you don't remove those biases, because there's a goal that you want to reach, which is an ethical goal. So, for example, if you want to support, for example, certain unprivileged part of people, you have to be biased. But there's a bias. So, again, bias, you have to discuss what is good and bad. I mean, it's not bias per se. It's neither good nor bad. It depends on...
Right, but what I'm trying to say is that my understanding is that ethics is a complicated subject, and remaining on the surface might push people into saying things that are wrong in practice, and even wrong ethically.
Well, yeah. So I agree. What I'm saying is that this these ethical deliberations that you need to, in some cases, are something that require expertise that comes from others, and we have to be able to interact with those. It's not you who say, now I am the ethicist, okay? It requires, there's a professionalism there. I totally agree. So ethical thinking is important. So how to make ethics and ethical deliberations part of education and practice of software engineering. As I said, ethics and ethical deliberations, concern three dimensions: the human values, the societal values, and the environment values. Okay, so I already said that. The point is that they should lead to taking responsibility. So in software engineering, in software development, what is the current approaches? I mean, if you're looking at the societies, both the ACM, the IEEE, they're coming out with ethical recommendations, for AI ethics, for others. So professionals are becoming aware of that. I looked at those, and they are okay, but they are not actionable. So we have to make those into something that people use, actually. So make them actionable. I think that that's the main challenge. So I'm skipping this. I thought it was being shorter. So the goal is to make ethics actionable in the conception and construction of socio-technical systems. So those ethical deliberations, which is discussing, understanding what is good and what is bad, what is right, what is wrong, as I said before, they should be first-class elements in the process of systems development. Not all systems. You have to understand how much that is important for the system in hand. But the difficulties are, who should be involved? The other difficulty is that, most decisions are not binary. How do you specify then those decisions? How do you verify those decisions? How do you validate those? These are all questions that are not clear. Now, who decides? I think I already said that, so let me skip. Yeah, let me give you two examples in which, there are interesting efforts into doing this. So at Technical University of Munich, and in particular at the, with the Bavarian Research Institute on Digital Transformation, there is a research effort which is going on with the collaboration of a software engineering professor and a philosopher. So what the purpose of that research is what they call software engineering by design. So what they are doing is that they're developing they're tailoring agile software development approaches in which ethical deliberations are part of the process. Okay, and they're trying to make it, package as a methodology that other people can use. There's a line of research, headed by, our colleague Bashar Nusseibeh, which is called Responsible Software Engineering at Lero, Ireland, and Open University in the UK. These are just two examples of approaches that I have seen in which they do that. So what I'm saying is that in many cases, what you need to do is to enrich the technical perspective with other perspectives that are, of course, depending on the context, which bring ethical, social, legal, political, depending on the type of system that you're developing, into the design of the system, the identification of goals and requirements, and the shaping of the system. So in the requirements, They should help understand, how can ethics and stakeholder values be addressed in the process. What kind of support you can provide for those ethical deliberations. We have seen an example before, which is, this approach integrating, the ethical deliberations into agile processes. But, there's also other kinds, of participatory design in which, stakeholders coming, from the constituency can provide inputs on the system that has to be designed instead of being the system imposed on the people. Validation, verification, continuous evolution should all be supported in that sense. In terms of research, I think that one of the, besides, what I said before, research is needed more and more to make systems less opaque. So transparency of the systems that we develop should be a goal. Transparency is needed for responsible use and trust at all levels, from users to designers to policymakers, regulators, depending on the system, at all those levels. You need transparency. Now, how do we, first of all, transparency cross-cuts all the levels of the of software, from goals, requirements, designs, assurances, the internals of the software. I think that we as software engineers have to do more and more is to provide ways to make systems visible, transparent, through trusted views. We need different views for different people, including the end users, who today are just asked to accept boxes of the software systems that they use, into which they have no visibility at all. Right? So I think that we need, if we want to have responsible use, responsible citizens, people who participate, visibility is the first thing that you have to provide. And visibility through transparency. So you have to be able to explain through trusted views. Trusted means that those views are not, there is a traceable proof that that view is faithful at all levels. I think that this is our responsibility in this world, because we are responsible for this world. We have to provide this. Yes?
In your view, whether ChatGPT satisfied your view?
No.
Precisely.
Well, yeah, yes.
So this is a big problem.
This is a big problem. Yes. But do we take a collective response to these big problems?
The Singapore government, several ministers recently emphasized on this.
Okay, even the EU also, and
There was some law implemented.
yeah.
That's important. I mean, if you don't have the government to enforce this one.
I absolutely agree. But there are some governments where who do this, others don't do it. I totally agree. But and I would say something more. We also have to participate in these efforts. We as technical people. Because regulation has to be sound, based on. Okay, well, that's another thing. So, but transparency. So it's critical, yes. So, it's first of all main responsibility of designers. So with this, I think that this is a real. I mean, this is the main research area, and we are not there, making our designs transparent. Well, then it has to be adaptive because, as I said, everybody should be able to get a view. Okay, so education. I'm trying to close. So, how do we educate people to live in this world? So, well, first of all, I believe that our software engineers, when we educate people in software engineering, well, they should, when we educate them, start, experiencing designing systems with other people, co-designing. So we have to expose them to the challenges of interacting with the social scientist on designing a system which has some social values, to understand, what are the issues that you have to take into account. We never expose our students to these kinds of projects. Most of the projects are invented within our pure technological domains. So I believe that this is a very important thing. So you have, in this way, we have to also break some of the silos that we are building, between, the social science students who don't interact with computing, and they have to, because in the real world they have to. So we should take advantage of this, being in a university environment, and do more of that. So this is one thing. Then, make our CS curricula digital humanism aware. Well, of course, bottom line, ethics should be there. But, we should, again, encourage taking courses also from humanities and social sciences. We have been reducing the amount of interdisciplinarity. I think, the world requires more of that. Of course, it's always a hard decision, We want to achieve this without compromising depth, technical depth. And this is the challenge that we have to face as educators. And as I said, I think it's very important to include cross-discipline lab activities, mixing students, mentors from different backgrounds on co-designing. Finally, I already told you about, can we as humans in general be beyond education, really drive society in a way that it evolves for the good for everybody. I want to tell you a little bit, and I'm closing, about this initiative on the digital humanism, which, brought me into rethinking, the rethinking that I've been discussing here, and other things. So it started, with this, with a group in Vienna. So it started by chance, with a group of 4 people, including maybe, Moshe Vardi, Edward Lee from Berkeley. I don't know if you know the others. Anyway, a group of us met for some reason in Vienna, and we started discussing, and we started a number of initiatives. There was a workshop and a manifesto written, which you can find, if you're interested, there is a lot of material online on this, interdisciplinary type of work that we have been doing. So there has been a workshop and a manifesto written, lecture series. It's almost, at least one a month or more, which is publicly, they're publicly available on YouTube. You can participate and see if you're interested in these topics, participate remotely. We produced in 2022 an open access book with, let's say, position statements from around this by people coming from very different areas, from political sciences to social sciences to, computing. And, amazingly, this book has been downloaded more than 400K times, which, is a little sign that it might be of interest of, a growing community of people. And this is the book, Perspective on Digital Humanism. There are summer schools in which we brought together PhD students, mostly, from Europe, but also from elsewhere, but from different communities, again, social sciences, to computer science. There are a number of activities that we sponsor: research, innovation, education, a roadmap, and we also produced actually something oriented towards being a textbook. It just came out. I still haven't seen the printed copy. It was shipped to my home while I was here. So again, I mean, it's I'm one of the co-editors of this, but there's contributions from many people, including probably some people that you might know. So this is, if you're interested, I mean, if you want to know more about this, you might look at this website. And actually, those are all open access. So we also are a believer in open access publications. If you're interested, you can download them. So, yeah, just closing, again, going back to history. It has been surprising that this happened in Vienna. I don't want to make, the same parallel, but another important thing happened in Vienna, which brought together people from different disciplines. And that was, I don't know how familiar you are, but this is a wonderful book, Exact Thinking in Demented Times, which describes what is called as the Vienna Circle. The Vienna Circle was a group of people from philosophy to science, various kinds of science, which got together to discuss, the effects of the radical changes, again, in mathematics, in physics, relativity, quantum physics. They were born at that time. And that had given a lot of interest in philosophers, in new ways of looking at the world. So there was this circle, which, of course, then was, had to disappear, when the Nazis went to Vienna. But, it involved, these people, Gödel, Carnap, Hilbert, Einstein, Boltzmann, Mach, Poincaré, Bernard Russell, Wittgenstein. I mean, these people, coordinated by these three philosophers. So by chance, also this digital humanism thing happened in Vienna, and it's just a parallel that is interesting to find. Anyway, so I'm done. Other initiatives, if you're interested, for example, again, there's this initiative on people-centered internet. I don't know if you're aware of that. One of them, actually, this lady is from Hong Kong, from Singapore. But Vint Cerf, you probably know him, is one of the creators of the internet. There's this Center for Humane Technology. So there's a growing interest around these themes. I have no recipes. You ask me, what is your solution to this? I don't have a solution. But I think I have a problem. And I would like to ask you to solve the problem. Okay? Thank you very much for listening. And, if you have more questions, I'll be happy.
Singapore government usually set a committee. The committee will get many people from different areas. And then maybe after that we become some sort of law. Of course, this sort of law will be different from other countries, like Singapore. If you have the gun illegally, you may get that sentence.
Well,
I mean, basically that's a case.
I agree. I was mentioning before, in Europe, the European Parliament, came out with a statement which is called the AI Act, in which, certain things are mandated for certain different types of AI systems in terms of transparency. The EU Parliament before did another, for me, important thing, which is the GDPR, for data protection. And the way, that happened, was done by, the European Parliament, but there was a lot of involvement And actually, at some point, even the AI Act was in danger, because of pressure from the known actors not to approve it. But it has been approved. So it's hard. Regulation is important. I think that not only regulation has to be good, because you don't want to over-regulate. There's dangers, but there's a threat that you want the regulation to address. And I think that this, again, is putting responsibility on technologists, because they have to participate, provide inputs in those processes to make sure that they are sound from a technical perspective. Yeah. Yes?
I mean, some of the recent regulation, particularly the EU is a leader in this regard. My impression is some of it is a bit like wishful thinking. That you have the regulation, but the specifics are unclear, enforcement is a problem, and is not clear as expected. And I'm not so sure about the practical implementation. And I'm not saying it's not good to have some regulation.
No,
It seems rather vague.
I agree. Part of it is, I think, in part also a research input for us to make some of the principles that are in those rules enforceable.
Right. And of course, the other problem I think that I don't think we have the technical solution to the regulation.
What you mean?
So suppose you want to verify that a program meets, or that some software system meets all those boxes. Because they're like tick boxes. I don't think we can.
Yes and no. I kind of disagree. It may be not perfect, okay? But you can do your best effort to make sure that those rules are satisfied. It may not be mechanical, it may be hard to enforce, but I think that, if those principles are the right principles that the rule wants to capture, I believe that it's good to have them. That's my stand, my opinion.
We are regulation. There's no execution power. That's the point. If you don't make it as the law.
Yeah, but what he's saying is that you can come out with rules that that are hard to enforce.
Those are laws, but the problem is that enforcement may be.
Yeah.
Right. So there is 1 more minute left. Yeah, 1 minute and 15 seconds. Yeah. If there is any last question. Yeah. Yeah. If not, maybe we thank Carlo for this forward-looking perspective